folks, welcome back to another video. Today we're looking at question 912, sort and array. The way we'll be solving this problem is by using a tree map. So tree map basically is sort of like a hash map, but it stores the value, the keys in an ascending order. So that will help us rearrange the array to help us sort it. The time complexity and the space complexity are within the requirements of the question. There's another method that we could have used, which basically is the merge sort method, but the space complexity in merge sort is also O of n, and it's a little more complex because you'll have to take an array, keep dividing it until you basically get like two elements, like swap them and keep merging them together. So since this method also meets the requirements of the space and time complexity for the question, I decided to go with the solution. So let's get started. So tree map, basically both of them are integers. Map is equal to new tree map. So basically you iterate through all of the numbers in nums, and that becomes map dot put num, and then becomes map dot get our default num over 0 plus 1. So what's happening here? So basically we're saying take this map, put the number, and every single time just increment it by 1. But what's happening here? Get our default basically what it's trying to do is you're trying to get the value and add 1 to it, but if the value doesn't exist, basically this part of the code is saying get the default value as 0 and then add 1 to that. So that takes care of the edge cases where the element doesn't exist in the map as of yet. And then the next part of the problem is relatively simple. So we initialize an index integer to be 0 for int num in map.keyset, I think it is. I think I should be able to get all the key sets. And for int I equals 0, I less than map.get num I plus plus. We could also bring this value as, store this value as f, so that we don't keep calling this method again and again. And f basically stands for frequency, less than f I plus plus, and then here nums of index equals num. Yeah, and then you need to increment the index, so this takes care of it, and then in the end you just return nums. I think this is all we need. Let's try compiling it. The first few test cases are okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity. The time complexity of the entire solution is O of n, since inserting anything into a tree map takes log of n time, and since we're doing that for n element, it'll be n log n. The space complexity is also of n, since we are using a tree map to store the numbers. Awesome, that's how we solve this problem. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I truly appreciate that. Keeps me motivated to make more videos. Thanks so much, and I'll see you folks soon. Peace.